Hello children, hope you all are doing well. This is VKM. Welcome to VKM Academy. In this lecture, we will be continuing with aromaticity, remaining part. Aromaticity, we have gone through all the rules as well as we have gone through even how to decide whether the compound is aromatic or non-aromatic or anti-aromatic. Now in this lecture, we will be talking about some examples. All these are very important examples. It will give you a crystal clear idea about aromaticity concept. So let's start the video lecture, and we need to identify whether the compound is aromatic or not, whether the compound is aromatic or non-aromatic or anti-aromatic, right? We will check with these examples. Let's see the first compound. We have here cyclopropene. But here there is no conjugation. Whenever there is no conjugation, we cannot consider aromaticity. So this compound is non-aromatic. Na, I am writing it as non-aromatic. If it is Aa, anti-aromatic. If it is A, aromatic. Okay. So now, and here itself it is cyclopropenyl anion. There is 2 pi electrons here, and this pi bond is in conjugation with this negative charge. Negative charge are lone pair. Negative charge are lone pair, and this pi electron is in conjugation. So 4 pi electrons, there is a closed conjugation, but it is satisfying 4n pi rule. If it is satisfying 4n pi rule, in the sense this compound is anti-aromatic. AA stands for anti-aromatic, but not stylish star Allu Arjun. Okay, and here cyclopropenyl cation. Cyclopropenyl cation, if you notice it, there are 2 pi electrons, but there is a closed conjugation. 2 pi electrons, in the sense it is satisfying 4n plus 2 pi rule, and hence it is an example of aromatic. And here cyclobutynyl dication. Cyclobutynyl dication, this positive charge, this pi bond is in conjugation with these 2 positive charges, and there are 2 pi electrons, and this compound is also aromatic compound. When it comes to here cyclobutynyl dianion, if you check it there. So cyclobutynyl dianion, total number of pi electrons are 6 pi electrons, because this negative charge also can be considered as 2 pi electrons, children. So pi and that negative charge and this pi negative charge conjugation, 6 pi electrons are there in this system. So this compound is also aromatic compound. In the same way, here if you notice it, there is no closed conjugation, only 1 pi bond is there. If only 1 pi bond is there, in the sense there is no closed conjugation, means the compound is non-aromatic, that is Na. Hope that is clear. When it comes to here, so pi, this pi is in conjugation with the lone pair of oxygen. Pi lone pair conjugation is there, but when it comes to here pi sigma sigma, there is no closed conjugation. When there is no closed conjugation, compound is non-aromatic. Na, right? Na means non-aromatic. It doesn't mean not allowed. Okay. And when it comes to this compound number 8, if you notice it, there is no closed conjugation. Pi is there. There is no pi-pi conjugation. If there is no pi-pi conjugation, in that case, the conjugation is not closed conjugation. Now the compound is to be taken it as non-aromatic. And in the similar way, you can notice it other compound also. 9th one, if you notice it here, this is pi and here 2 electrons, total 6 pi electrons are there. 6 pi electrons means obviously the compound is aromatic compound. And when it comes to here cyclopentadienal cation, there are how many pi electrons? 4 pi electrons. There is a closed conjugation, right? There is a closed conjugation, 4 pi electrons, but the compound is anti-aromatic. Compound is anti-aromatic. When it comes to here, this compound number 11, if you just notice it, here 4 pi electrons, and this pi is in conjugation with the vacant orbital of the boron. Conjugation is present throughout that, but pi electrons are 4. When pi electrons are 4, in the sense that compound is treated as anti-aromatic compound. Again anti-aromatic compound. And here itself, if you notice it, yes, pi, it is in conjugation with the lone pair of oxygen, isn't it? The pi lone pair and positive charge lone pair pi, and it's a closed conjugation. There is a closed conjugation. Total number of pi electrons are 6 pi electrons, and the compound is aromatic compound. And this compound is called as aromatic compound. When it comes to here also, same thing is applicable, pi, and here lone pairs on oxygen. Lone pairs on oxygen is in conjugation with pi bond. Boron is having vacant orbital. In the similar way here, positive charge also. In compound number 12, if you notice it, positive charge means vacant orbital. In the same way here, boron has vacant orbital. There is a closed conjugation and 6 pi electrons are there. So 6 pi electrons are there means compound is aromatic. When it comes to here, it's called cyclobutadiene. There are how many electrons? 4 pi electrons. 4 pi electrons means compound is anti-aromatic because it has closed conjugation and anti-aromatic. This compound, it is an example of heterocyclic compound, children. Heterocyclic compound, and it has how many pi electrons? 6 pi electrons, because this lone pair is involved in conjugation. As I already discussed about this example, it is aromatic. Same way thiophene, it has lone pairs. One lone pair is localized, another lone pair is delocalized. It is also aromatic. And here also, this lone pair is involved in conjugation. Total number of pi electrons are 6 pi electrons, and this is also aromatic. When it comes to here, this lone pair is in conjugation with pi, and this pi conjugation is not maintaining with this another pi bond. There is no closed conjugation. If there is no closed conjugation, and the compound is to be taken it as non-aromatic compound. And when it comes to here there is a lone pair. This lone pair is involved in conjugation with this pi, and pi positive charge conjugation is also there. Conjugation is throughout system, that is throughout cyclic system, and moreover throughout cyclic system closed conjugation is there. Moreover 6 pi electrons are also there. So this compound can be taken as aromatic. If you notice this 20th compound, there is no closed conjugation. There is no closed conjugation means compound is taken as non-aromatic. When it comes to here, if you check it here, this lone pair is involved in conjugation. Pi lone pair, but total number of pi electrons are equal to how many? 8 pi electrons. If 8 pi electrons are there means it is satisfying 4n pi rule. 4n pi rule in the sense this compound is anti-aromatic. Hope you understood that. Yeah. We will continue with the remaining set of examples also. After that, next set of examples, if you notice it, this is most popular cation, children. Most popular cation, it is said to be tropylium cation. In the tropylium cation, there are how many pi electrons? 6 pi electrons, 2, 2, 2. And there is a closed conjugation. 6 pi electrons and closed conjugation, so the compound is aromatic. Right? And this compound, there is no conjugation here. If you check it here, pi, these are separated by 2 sigma bonds, and hence it is example of non-aromatic. And when it comes to here, so let us say this lone pair, and lone pair is involved in conjugation. Pi conjugation, this lone pair pi conjugation, but if you polarize the bond here, CO, oxygen is more electronegative, here plus and here minus, then this positive charge also is in conjugation. Lone pair pi and positive charge, but number of pi electrons are equal to how many? 6 pi electrons, children. So 6 pi electrons means compound is also aromatic. When it comes to here, if you polarize the bond in this way, it is plus and it is minus, and it is lone pair, and this lone pair is involved in conjugation. Lone pair pi positive charge and pi lone pair, and that indicates number of pi electrons are equal to how many? 6 pi electrons are there. So compound is aromatic. And here same thing is applicable, and here also you can polarize the bond. Pi, sigma, and here positive charge and lone pair. There are 6 pi electrons. Total number of electrons are 6 pi electrons. If 6 pi electrons are there, then it is an example of aromatic. Now in the similar way, here if you notice it, here 6 pi electrons also there. Here positive charge. There is a closed conjugation. If there is a closed conjugation, total number of pi electrons are 6. Closed conjugation is present, and hence it is an example of aromatic. And next one, here there is a closed conjugation even lone pairs are not involving also, there is a closed conjugation. That means all lone pairs are localized. All lone pairs are localized. There are 6 pi electrons. 6 pi electrons means obviously compound is aromatic. That compound is aromatic. When it comes to here, same thing. But here if you notice it, okay, this is pi, sigma, pi, sigma, pi. Even lone pairs are also not involving. Here also lone pairs are localized. But it is also 6 pi electrons, closed conjugation is there. This is also can be taken it as aromatic. When it comes to here, if you just notice it, there is no pi-pi conjugation. Here, there is a separation, sigma, sigma. Total number of pi electrons are 6 pi electrons. But there is no closed conjugation. And hence this compound is non-aromatic. It's not aromatic. And here if you notice it, there is 6 pi electrons. There is a closed conjugation. So closed conjugation means compound is aromatic. Here if you notice it, this nitrogen lone pair is not involving in conjugation. Check it, pi, sigma, and lone pair. This lone pair is delocalized, but this lone pair is localized. So there are 6 pi electrons. N value will be equal to 1 according to Huckel's rule. Compound is aromatic. Here also same thing. This lone pair is localized. And pi lone pair pi conjugation, so 6 pi electrons are there, compound is aromatic. And when it comes to here, this lone pair is localized, it's not involved in conjugation, but this lone pair is involved in conjugation. 6 pi electrons here also, compound is aromatic. Hope you are following it, everyone. Is that clear? So how we are actually identifying the compound is aromatic or non-aromatic or anti-aromatic? Aromatic, anti-aromatic rules are same. Both rules are same. Only the difference is anti-aromatic means it follows 4n pi rule, whereas aromatic means it follows 4n plus 2 pi rule, Huckel's rule. When it comes to this compound, see the closed conjugation pi, negative charge, pi, and here pi. There is a closed conjugation. 1, 2, 3, 4, 5. 5 2s are 10. 10 pi electrons, same like naphthalene. So it is also aromatic. And this compound 1, 2, 3, 4, 5, 6. 6 pi bonds. 6 pi bonds means 12 pi electrons. 12 pi electrons in the sense it follows 4n pi rule. It follows 4n pi rule. 4n pi rule means anti-aromatic. Okay? It is most unstable compound. When it comes to here, there is a closed conjugation. Check it. There is a closed conjugation. Total number of pi electrons are 10. Same like this compound, 10 pi electrons. It is aromatic. Boron is having vacant orbital. There is a conjugation, pi, and this vacant orbital conjugation is there. And hence, number of pi electrons are 6. So this compound is also aromatic. When it comes to here, there is a, okay, instead of lone pair, so we have a negative charge over there. Negative charge pi and sigma pi. Conjugation is there. So 6 pi electrons aromatic. And here itself if you check it, lone pair pi, sigma pi. But here sigma, sigma. That means there is no closed conjugation. Closed conjugation is the essential condition. No? If there is no closed conjugation, this compound is non-aromatic. Hope that is clear, children. So this will give you a crystal clear idea about identification of a compound, whether it is aromatic or non-aromatic or anti-aromatic, right? So already these are 40 examples I have given. During the lecture time also I have given few more examples. All together will give you a clear idea. Hope you like this video. So if you like it, okay, please click on like button. If you have not subscribed, please subscribe to channel. It would be a great boost up for my further videos. Subscribe to my channel VKM Academy. In this, okay, in the next lecture, we will be continuing with another topic. Until then, bye. Signing off. Thank you very much.